All right, so in this video we're going to talk about the different ways in which you can select a sample. All right, particularly a good sample, right? The key to a good sample is that it has to be representative of the population. That is the biggest thing, is that it's representative, that it looks like a mini population, right? It looks just like the population, but on a smaller scale, right? So how do we make sure that our sample is representative? We sample randomly, and we do our best to avoid bias. So remember, size is not that important, okay? Bigger samples do give us more accurate results, and we'll learn more about that when we talk about inference in chapters 8, 9, and 10. But just because you have a large population does not mean that your sample needs to be large, okay? There's many situations in which you can get away with a sample of 20, 30, 50, 100. You don't need 1,000 or 10,000 people. And believe it or not, a sample of about 1,000 to 1,500 is the perfect size for a to represent the entire U.S. adult population of many millions of people. So there's different ways to draw the sample, okay? Our main one that we're going to use most of the class is what's called a simple random sample, or often abbreviated SRS. So this is like putting everybody's name in everybody in the population, taking their name, putting it into a hat, shaking it up, and drawing out names at random. Okay? Each individual that's in the population has the same chance of selection. Technically, we're drawing with replacement, but in reality, not so much, right? In addition to everybody having an equal chance of selection, every combination of individuals, like if you're going to select 10 people, every combination of 10 people from the population has the same chance to be the sample that's selected, all right? So this is just, it's a simple random sample. It's the simplest sampling technique you can do. All right. So, and that's what this picture over here is showing. We have our population of 12 individuals, and we just randomly pick 4 of them to be in our sample. Okay. Then another common one is what's called stratified random samples, or stratified sampling. And this is like going one more level of complexity than a simple random sample. It helps ensure against possible non-representative samples, okay? Because every once in a while with a simple random sample, you might get a sample that's not that representative. Because like looking here, we've got 6 reds, 3 greens, and 3 blue people. And so if we're only selecting 4, it wouldn't be uncommon or unheard of for our random sample of 4 to not have any green people in it, right? So if we were to say, oh, I want to make sure that I have red people, blue people, and green people in my sample, and I want them to be proportional to their sizes in the overall population, that's when you would use a stratified random sample. So here what you're going to do is you're going to take your population, divide it into groups. In this case, we've got the blue group, the red group, and the green group, right? So this is based on some characteristic of the population, right? So blue, red, green, and then you draw randomly from each of the groups. So here, we're picking 4 people, and so we see that blue is 25% of the population, so we're going to draw 25% of our sample of size 4, or 1 person from the blue group. And then same kind of story with the red group. They're 50% of the population, so we're going to draw 50% of our sample, or 2 people from the red group. And then same thing with the green group, right? And so as another example, let's suppose Clayton State is 60% female and 40% male. It's more like 70%, but whatever. We want a sample of 50 students. How should I draw my sample? We would say, well, hey, let's draw 60% of 50, which is going to be 30, 30, from the females at Clayton State, and we're going to draw randomly, of course, 20 from the males. Right? So we're going to say, hey, here's our females, here's our males, and we're going to draw 60% from the female group, 40% from the male group. And then at least on gender lines, our sample is the same proportions as the population. Okay, some other sampling designs. There are lots of other designs. Multi-stage sampling. Basically, if it's sounding really complicated, it's probably a multi-stage sample. That technique uses several different methods that are kind of combined together. Okay, cluster sampling sounds a lot like stratified random sampling, but you'll notice with stratified sampling, you're dividing into groups that are the same within each group, right? All women, all men, all blue people, all red people, all green people. With cluster samples, you're dividing the population into groups, but they're not necessarily homogeneous. So you're dividing them into groups that are now called clusters instead of strata, and you're randomly selecting some of the clusters and pulling everybody from that cluster. So for instance, here you've got our population. We've divided it into 6 groups, 6 clusters, and we've randomly selected these 2 groups or clusters to be our sample. Everybody from each of the selected clusters gets included in the sample, versus stratified, where you're randomly selecting from each of those groups. Cluster sample, you're randomly selecting groups and using everybody. Okay, systematic random sample, that's an easy one. That's saying, hey, I'm going to take every 5th person or 3rd person or whatever in the list that I have, or in the line of individuals that I have. Right? There's a system to the selection. Okay, so the randomness there comes in the selection of which person is selected first. Okay, so the key element is that in every one of these, there is a random selection, right? Random selection in every one of these techniques at some stage in the game, right? So the first person randomly selected. Okay. So we're going to deal with simple random samples primarily, but every once in a while you might see cluster or systematic or stratified random sample pop up, especially in Chapter 1, where we're learning about vocabulary. All right, so we're going to go on to some examples, and we're going to put those in the next videos.